Questions 5 through 7 on the 2009 Grade 12 Euclid Math Contest. In the diagram, ABC is isosceles with AC equal to BC equal to 7. Point D is on AB with CDA equal to 60, AD is 8, and CD is 3. Determine the length of BD. In this diagram, I'll label the length of BD as x right here. And since this angle is 60, this angle has to be 120. Since the angles about a line add up to 180. So therefore, on this triangle right here, I can use the law of cosines. So that will give me 7 squared is equal to 3 squared plus x squared minus 2 times 3 times x cos of 120. This is putting everything on one side, x squared plus 9 minus 49 minus 6x cos of 120, which is negative a half. And that is equal to 0. So this becomes x squared plus 3x minus 40 is equal to 0. And if you factor this, you get x, 8, 5, positive, negative. So that gives me values of x is equal to 5 or negative 8. Of course, x cannot be negative 8 since x represents a distance, so x can only be 5. And that is the required length that they want, which is BD. In the diagram, ABC is a right angled at C. Also, 2 sine B is equal to 3 tan A. Determine the measure of angle A. Well, immediately you can deduce that A squared plus B squared is equal to C squared, since that is a right angle using Pythagoras. And then they give us this important clue that 2 sine B is equal to 3 tan A. Okay, well, let's see what we can do there. The sine of B, in terms of the lettering system that they have used, is B over C. And the tan of A, using their letters, is A over B. So we can manipulate this in any way, really. I don't know, if you cross multiply, you get B squared is equal to AC. And I guess we retain the coefficients. And then we'll see later on how we want to manipulate this, because right now I'm not entirely sure. Now, once again, as the previous part, we will use the law of cosines. And the triangle that we're going to use it on, of course, is this triangle, but the angle is this angle right here. So it will become A squared is equal to B squared plus C squared minus 2BC cos A. And let's see here, A squared, well, at this point I think I will substitute that in. I was wondering where that would be beneficial, so I think here that might be helpful. I hope it's helpful. And then the C squared, again, I think I'll put in this guy right here. So that will give me A squared plus B squared. And then I've got this minus 2BC cos A. And if you do that, you'll notice that these A squareds cancel. So that's very helpful. Now, I want some sort of trigonometry relationships, and I think I will be able to get that if I divide through by B squared. So if I do that, I get 3 over 2, A over B, C over B. B squared divided by B squared just gives me 1. And then this will be 2B over B, C over B, and then cos A. And I think this will be helpful for us to solve this. So let's see, what does this give me here? 3 over 2. Okay, now I'm going to start subbing in trigonometry. A over B in this triangle right here, we'll keep that in the screen, is equivalent to the tan of A. So that's this guy right here. C over B is equivalent to 1 over the sine, or we can just write 1 over the cos of A is actually the perfect description for C over B. Then we've got this 1, then minus 2, the B over B just becomes 1, and then C over B, which again is 1 over cos A. And that's times cos A. Okay, so now we can move this up. Okay, this is very manageable, I hope. We've got 0 is equal to 3 over 2. Tan, of course, is sine over cos, like that. And then we've got 1, and then this just cancels and becomes just minus 2. So that's very helpful. And if you were to simplify this, this becomes 3 over 2 sine of A cos squared A. And 1 minus 2 is negative 1, but if I put it on the other side, it just becomes 1 like that. If I cross multiply, I get 2 cos squared A is equal to 3 sine of A. Now, it would be nice if we had just one trigonometric expression, like just sine or cos. We have 2, but that's not a problem, because if you remember, cos squared A plus sine squared A is always equal to 1. So instead of cos squared A, I can substitute 1 minus sine squared A, and that will allow me to have only sines in my equation, like that. And then at this point, I will just put everything on one side. When I expand this all out and put it all on one side, it will be minus 2 sine squared A minus 3 sine A plus 2. And then I can, of course, multiply through by negative 1, make it a little bit better looking, like that. And I think this factors. If I factor out a sine A, it will be, let's see here, 2 sine A, like that. And then I believe 1 and 2 minus plus. So, and of course that's equal to 0. So that means that the sine of A is equal to either negative 2 or the sine of A, 2 sine A, is equal to 1. Now this is inadmissible because the sine of something can only be between negative 1 and 1, right? So because the sine of A is anywhere between negative 1 and 1. So this is the only solution. So that means the sine of A is equal to 1/2. And if that is indeed the case, that means A is 30 degrees. And that was what they were looking for in this question. Determine the measure of angle A. An integer n with 100 less than or equal to n less than or equal to 999 is chosen at random. What is the probability that the sum of the digits of n is 24? So n is anywhere between 100 and 999 inclusive. So how many numbers is that? Well, that looks like a total of 900 numbers. So when we figure out our probability, it will be something over 900. Now the 900 is the denominator, but the numerator, of course, is our specific condition, which is that when you have this 3-digit number, A, B, C being those 3 digits, that the sum of the digits is 24. All right, let's work with this. Let's just talk about A. What can A be, first of all? Well, A can't be 1, 2, 3, 4, or 5. Why is that, though? Because if it's one of any of these numbers, there's no way that B plus C can equal 24, because remember, B and C are just individual digits. They range anywhere from 0 to 9. And even if you had both of them maxed out at 9, you would need A to be at least 6 for that sum to be 24. So let's choose 6. And if we do, then of course, as I just said, 699, that satisfies. And that's the only one that we get when A is 6. All right, what about if A is 7? If A is 7, we can use 9, 8, and we can use 8, 9. So that gives me 2 more. How about when A is 8? When A is 8, we can have 9, 7, 7, 9, and we can have 8, 8, 8. That will satisfy the conditions. And the very last digit that A could possibly be is 9. And if it is, then we can have 9, 6, 6, 6, 9. Or we can have 8, 7, and 7, 8. These ones will all satisfy that condition. And there's 4 of those. So if you add up all these guys, it is 10. So that numerator is 10. And in lowest terms, of course, this will be 1 over 90. So that's the probability. Alice drove from town E to town F at a constant speed of 60 kilometers an hour. Bob drove from F to E along the same road, also at a constant speed. They started their journeys at the same time and passed each other at point G. Alice drove from G to F in 45 minutes. Bob drove from G to E in 20 minutes. Determine Bob's constant speed. So let's draw this diagram just a little bit bigger. It will help us, I think. And let's label this now. This is E. Somewhere in here is G. And this is F. And this time is the time that Alice takes. And I'll just call that TA1 for Alice. And this time that it takes Bob to go from F to G, I'll call TB1, the time Bob takes. Now, in addition, they're talking about 2 other scenarios. The other scenario is Alice driving from G to F. So we have to take that into consideration. So we'll call that TA2, the time that Alice takes to go in the second half of her journey, or second part of her journey. And then, of course, similarly, that part needs to be discussed. That's when Bob is going from G to E. So I'll call that TB2. All right, so far so good. Nothing confusing, I hope. And then I will label, I don't know, they don't give me any distances, right? So I'll just call this distance from E to G, I'll just call that X. And the distance from G to F, I'll just call that Y. All right, so that's the setup of the question. Now, speed is equal to distance over time, and any variation of that formula is valid, like distance is equal to, time is equal to distance over speed, something like that. Now, the very first part of this question is that when Alice goes from E to G, and Bob goes from F to G, they meet at G, right? They tell you that. They start their journeys at the same time and passed each other at point G. They passed each other, but they obviously met at G also. So that means the amount of time that it takes Alice to go from here to here equals the amount of time it takes Bob to go from here to here. So that's the first thing, that TA1 is equal to TB1. So that's very important. Now the next part is going to be looking at these 2 guys right here, because they have a little bit of information for us. Let's look at TA2, the time that Alice takes in the second part of her journey. They tell me that that is 45 minutes. Now I've got to convert that to hours because our speeds are in kilometers per hour. So that's going to be 3/4 hour. Okay? And the formula for time is distance over speed. So this 3/4 is equal to the distance, her distance, which was going to be x, or sorry, it's this distance right here, because we're talking about TA2. So that distance is y, and the speed that Alice is going at is 60, because it's constant throughout her journey. So this allows me very quickly to figure out what is y. And it's going to be equal to 45. So there we go. I can put that in there, y is equal to 45. And in a very similar way, we will now talk about TB2, because they have a little bit of information for that. They tell me in the question that is 20 minutes. So that's 20 minutes. And in hours, that's going to be 1/3 hour. Right? So in a very similar way, using this formula, let's see if that helps us. 1/3 will be equal to the distance. So the distance in this case is x, since we're talking about TB2. And the speed actually, we don't know. They don't give us a Bob speed. Oh, that's what we have to actually figure out. Okay, I'll just write speed of Bob. So cross multiplying, I get the speed of Bob is equal to 3x. Okay, so far so good. Now, this is where this formula will come into play, and that will help us solve the question. So we have TA1 is equal to TB1. And TA1, if you use distance over speed, distance, of course, is x. And this is Alice, so her speed was 60. TB1, the distance is y, but we have a numerical value for y, it's 45. And the speed, it's Bob's speed, which is speed of Bob, SB. Cross multiplying, we get x SB is equal to 45 times 60. And we know that SB is equal to 3x, or x is equal to SB over 3. So we can substitute that in. So we got SB over 3 times SB, like that, is equal to 45 times 60. And then if we cross multiply, this is going to be SB squared will be 3 times 45 times 60. And that is 8,100 for SB squared. And therefore, if you take the square root of that, you will get 90 for SB. And SB represents the speed in kilometers per hour of Bob. And that is what they wanted us to figure out. The parabola y is equal to x squared minus 2x plus 4 is translated p units to the right and q units down. The x-intercepts of the resulting parabola are 3 and 5. What are the values of p and q? So we have some sort of a parabola. I'm not entirely sure what it looks like, but we can make a pretty decent estimate, I think, based on the information they've given us. And let's see here what kind of a sketch we can draw. Well, first and foremost, we have the equation. So let's just write it out, minus 2x plus 4. And what I'm going to do is write it in the form that allows me to figure out the vertex. And that form is y is equal to ax minus h squared plus k. And if you do, that means the vertex is hk. So this is going to be x squared minus 2x. Take half of this and square it. You have to complete the square to get it in that form. So half of this is negative 1. If you square that, it's 1. Then immediately you have to subtract it. And then don't forget about that 4. This part factors, and it becomes x minus 1 squared. And then this part is going to become 3. So this is the formula that allows me to figure out the vertex. And in this particular equation, the vertex is 1, 3. So that tells me the vertex, and also the coefficient is 1, positive 1. If you're wondering, this a, in this case, is just positive 1. So that means the parabola opens up upwards like that. So 1, 3, we don't need to make it too perfect here. Just a sketch to kind of illustrate how this will be. And it will be something like this, where this is the vertex right here. That vertex is 1, 3 in terms of its coordinates. And this point where it crosses the y-axis, that we can easily figure out. That's just the y-intercept. And you do that by setting x equal to 0. And if you set x equal to 0 there, you'll get y is equal to 1 plus 3, which is 4. So that point is 0, 4. Okay, so far we're just getting an idea. Now they tell me that this parabola, you go p units that way and then q units down like that. You're going to translate it. And when you do, it's going to end up somewhere here, but they help you by telling you that the resulting parabola has x-intercepts of 3 and 5. So if this is 3 and this is 5, it will cross like this, approximately. So this parabola basically comes over and then comes back down like that. Exact same shape, but now it's just been translated. And we have to figure out what is P, how many units was it translated to the right, and what is Q, how many units was it translated to the bottom, how many units was it shifted down. Well, if this is 3 and this is 4, because of the symmetry, this is 3 and this is 5 actually. Because of the symmetry, this is 4. That means this is the vertex, and that vertex is going to have an x-coordinate of 4. And the y-coordinate we don't know yet, but at least we know the x-coordinate we can figure out pretty quickly. So this new parabola right here, since we have a little bit of information, we can sort of guess the equation. It will be in this form, but it's exactly the same as that in terms of its shape. So it's going to have y is equal to 1 for a, x minus h plus k, where hk is the vertex. Well, I know that h minus this h right here that I have to subtract is 4. I just figured that out by just looking at the diagram. So now I just have to figure out the k, and that k will give me the necessary y-coordinate of the vertex. Okay, well, how do I do that? Well, I can easily do that because I know a point. I know 2 points on this graph. I know this one, which is 5, 0, and this one, which is 3, 0. So I'll just substitute one of those. I'll substitute 5, 0. So that means this is 0. We got 5 minus 4 squared plus k. So this gives me 1 plus k is 0. Therefore, k is equal to negative 1. So the equation of this parabola right here is y, I'll just write it right here. Y is equal to x minus 4 squared minus 1. So this is a negative 1. So we're almost done. All we now have to do is just compare the vertex here and the vertex there to figure out how many units was it shifted to the right and how many units was it shifted down. Well, to get P, which is right here, that's how many units are shifted to the right. Well, it went from 1 to 4. So obviously, P equals 3, since it was shifted from 1 to 4. So because to get that, you'd have to basically subtract 4 minus 1, right? You're going from 1 to 4. Obviously, it had to be shifted to the right 3 units. Now to get Q, we'll look at the y-coordinate of the vertex, the 2 vertex. And it went from 3 to negative 1. So it obviously was pushed down by 4. So Q is 4. And that's it. That's pretty much all they're asking us for. So P is 3 and Q is 4. In the diagram, D is the vertex of a parabola. The parabola cuts the x-axis at A and at C for 0. The parabola cuts the y-axis at B, 0, negative 4. The area of ABC is 4. Determine the area of triangle DBC. Now, we don't know the equation of this parabola, so the standard form, of course, is ax minus h squared plus k, where hk is the vertex. Now, this particular parabola is pointing downward, so that tells me that this a is negative, so it's going to be like that. Now, any clues that they give us, let's see here. They tell me a couple points on the parabola. For example, 4, 0, and also 0, negative 4. So I'm going to substitute those points in to help me figure out what this equation looks like. So let's first put in 0 and 4, this guy right here. So when y is 0, we have negative a, x is 4, minus h squared plus k, like that. And then substitute this point, and we will get negative 4 is equal to negative a 0 minus h squared plus k. Now, we can subtract these two equations. That will help us get rid of the k's. So the top equation minus the bottom equation, so 0 minus 4, and then on this side it will be minus a 4 minus h squared plus k, and then minus a minus h squared minus k. So this is just 4, and the k's cancel, and then I've got to, let's see here, collect like terms, and if I do, I get minus a 4 minus h squared plus a h squared. And that's about as far as I can go for now. We'll see what happens a little bit later. Now let's go back to this diagram. They tell me that D right here is the vertex of the parabola. So that means that this vertex is my HK. Now, because of the symmetry, again, if I drop the line from there to there, this distance right here, this distance in there, is equivalent to 4 minus h. And because of the symmetry, that is also going to be 4 minus h, that distance. 4 minus h. All right? So if I were to look at their ABC being 4, ABC is right here, A to C to B, that triangle. And that triangle, we can write the formula as follows for the area. The area is going to be 1/2 base. The base will be AC. And the height will be from B all the way to the origin, and that's just going to be 4, right? So there we go. And they tell me that area is 4. So 4 is equivalent to 1/2 times AC. And AC is going to be 2 times 4 minus h, based on how I labeled it. So this will allow me to calculate h. And if I do, I get the 2's cancel, the 4's cancel, so this just becomes 1 is equal to 4 minus h, and therefore h is equal to 3. All right? So I've got one of my coordinates for the vertex, put that in there, 3. Now I'm interested in continuing and trying to figure out what is a and what is k, and that will, of course, help me. So let's figure this out. Let's put h equals 3 into this equation. So it's going to give me 4 is minus a. This is just going to be 1 squared plus 9a. So that means 4 is equal to 8a, and a is 1/2. So there we go. We just got 1/2. And now we can calculate k, I think. How do we get k? Well, k we can get with either of these equations up here. So, for example, just use this one. That means minus 4 is equal to minus 1/2, since a is 1/2. And then we know that h is 3, so this just becomes minus 3 squared plus k. So this becomes minus 4 is equal to minus 9 over 2 plus k. So this looks like k is going to be 1/2. So there we go. So grand finale, well, almost grand finale, is that we have the full form of the equation. It's minus a half x minus 3 squared plus a half. That's the equation of that parabola. Okay. Now, what do? We have to figure out the area of DBC. DBC. So this triangle right in here. D down to B to C right here. Now, how do we do that? Well, if I can figure out the length of C to B, that will behave as my base. That shouldn't be that hard. And then if I drop a perpendicular and figure out that distance, that can be my height. And that will allow me to figure out the area. So I blew up the diagram a little bit, and we figured out our H and our K previously. So I will just label D, which is the vertex, which is 3.5. Now very quickly, I want to figure out my base, and I want to figure out my height, and then I can figure out the area of that triangle. BC, which will be the base, we can figure that out with just those 2 points. 4 minus 0 squared, using the distance formula, 0 plus 4 squared, and this becomes root 32. So that part's pretty straightforward. But finding this height is a little bit more complicated. First thing we need to do is figure out the slope of that line. And that's going to be rise over run. So the slope of that line, I'll call it M1. If we look at it from this perspective, then the rise is going to be 4, and the run is also 4. So that slope is 1. Now this line, because it's perpendicular, its slope is the negative reciprocal, and the negative reciprocal of 1 is negative 1. So that line will have an equation of the form y is equal to minus 1x plus b, this line right here. And then to figure out b, I can just substitute in 1 point. So a half is equal to minus 1 times 3 plus b, and therefore b is equal to 3 plus a half, which is 7 over 2. So that allows me to figure out the equation, which is y is equal to minus x plus 7 over 2. And in a very similar way, we can figure out the equation of that line. We already know the slope was 1. So y is equal to x plus some b. And we can just substitute one of these points, and very quickly that allows us to figure out b. When x is 0, y is negative 4, right? Because this line has that point. So that means b is negative 4. So that equation is x minus 4. This equation is of this line, and this equation is of this line right here. And the intersection point will be right here, that point right there. Set these equal to each other, and we'll get the intersection point. X minus 4 is equal to minus x plus 7 over 2. So that means 2x is equal to 7 over 2 plus 4, which is 15 over 4. And therefore x is equal to 15 over 2. X is equal to 15 over 4. And then if you substitute that into any one of these equations, either this one or this one, you can get the value of y. And if you do, you get a value of y is equal to negative a quarter. So now, final step is figuring out DC, or CD, that length. And we can do that using the distance formula. Actually, it's not DC. Let me label something here. Let me call that point E. DC is this guy. We're not trying to figure out DC. We're trying to figure out DE. Sorry about that. And DE is what we have to figure out. That's going to be our height. So DE, that's pretty easy. You got these 2 points. So using the distance formula, we got 3 minus 15 over 4 squared plus a half minus a quarter minus negative a quarter, so it becomes plus a quarter, all under the square root. And this, when it's all said and done, is the square root of 9 over 8. So now we have the final step. Area of this triangle BCD is 1/2 base times height. The base is BC. The height I have designated as DE. And therefore 1/2 BC is root 32 up here. DE is right here, 9 over 8 root. And this looks like it will be 32 divided by 8 is 4. 4 times 9 is 36. So root 36, 1/2. Root 36 is 6, so 6 over 2. And that is just 3. So there we go. 3 is the area of the triangle DBC.